So we're on page 122, topic 21, and the problems that we're going to do from this page are number 5, shown here, and the second problem that we're going to do, representative problem, is number 8, shown here. So let's get started with number 5, and we're told that the cost Y in dollars of producing X units of a product is given by the following quadratic equation. So Y is the cost, X is the number of units that are being produced. So the first question that is being asked is, what is the cost of producing 26 units? That means X is 26. So if we substitute into this equation with X equals 26 and calculate Y, we will have the cost, and that's what's done over here. So we substitute X into Y equals the equation that we're given up here, 1.7x squared minus 51x plus 682.5. So we replace here, x squared becomes 26 squared. This x becomes 26 here, and we have the 682.5. So 1.7 times 26 squared. 1.7 is this. 26 times 26 gives you 676. 51 times 26 on your calculator will give you 1,326. And this stays 682.5. Now when you multiply 1.7 times 676, you're going to get $1,149.20. Subtract $1,326, add 682.5, and you get 505.7. So the cost of producing 26 units is $505.7, and that answers part A. Now part B is asking you, two parts actually, how many units are produced at what minimum cost? So because this graph is the coefficient of the x squared term is greater than 0, the parabola has a smile shape, and of course because of the smile, the parabola has a minimum. So where will that minimum be? We get the x value from the axis of symmetry, so minus b over 2a, and if we go back up here we can see that b is minus 51, so we put that in, and a is 1.7, so minus 51 is plus 51 over 2 times 1.7 is 3.4, and that tells us an x value of 15 is the axis of symmetry, and that represents the low point, the number of units that will result in a minimum cost. So the cost of producing these units, so we essentially here are calculating the vertex. We've got the x value, and now we're going to put in the calculate the y, putting in the x. So substitute x into 1.7x squared minus 51x plus 682.5. Here's the original equation. We substitute in 4x 15 squared here because of the x squared, minus 51 times x minus 51 times 15, and 682.5. 1.7 times 15 squared works out to 382.5. 51 times 15 becomes 765, and we have a minus sign because of this minus sign, and then we have the last term plus 682.5, and so we find that this has a cost of 300. So if you imagine the parabolas going down like this and up like that, then at the minimum point we have the vertex. The x value is the number of units, and the y value is the cost. So let's go look at number 8, and we have to read this a little carefully. The height h in feet of a ball x seconds after it's being thrown is given by h equals minus 8.5x squared plus 25x plus 6.5. So x represents the time after which the ball is thrown, and what is the corresponding height given by h. And it's not y here, I'm sorry, so I'm just going to correct that. Excuse me. And that should be h here, so I'm just going to correct that and put an h in here. Okay, fine. So x is the time, h is the height, and the first question is, first part A, is a little tricky. After how many seconds is the ball's height less than when it was released? Well, what you've got to imagine here is that when we start with x equal to 0 here, the height is 6.5. That means the ball was thrown from a height of 6.5. So consider that the ball started at 6.5. Then imagine the ball, here's 6.5, and it goes up and it goes up. Then eventually it'll calm down and it'll reach that height again of 6.5 before dropping to the ground. So 6.5 is where it was started. So we set h equal to 6.5, and then we need to find the other value where it reaches this height on the way down. So the ball has a parabolic path. It starts at 6.5, and on the way down it also reaches 6.5, and we need to know the time where it reaches 6.5. So we take the original equation, we put 6.5 in there, and then of course the 6.5 here and the 6.5 will cancel, and we're left with minus 8.5 x squared plus 25x equals 0. And we factor the x out of there and solve this part. If we make minus 8.5x plus 25 equal to 0 and solve for x, x will be 25 over 8.5, which is 2.94. So on the way down, after 2.94 seconds, this is the other time the ball is at a height of 6.5 meters. Now I'm just going to show you a little graph over here to give you some idea of what's happening. So you can imagine here is a ball. It starts at 6.5, then it goes up again, and it goes down, and here at another height of 6.5, because along this line is the value 6.5. And so at this point, this is the other time where it reaches that height of 6.5. Now, the second part is, when does the ball land? Well, the ball lands when h is 0. So we have to make this, the height is 0, that's when the ball lands. So we make the equation equal to 0, and we can't factor this. No way to factor this, so we're going to use the quadratic equation. And x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So, okay, minus b, right here, here's b, plus or minus b squared is 25 squared, minus 4a is minus 8.5 right here, and c is 6.5. So 25 squared is 625. 4 times 8.5 is 34, plus 34 because of the minus and the minus. 34 times 6.5 is 221. So now, when we add the 625 and the 221, we get 846. Everything else stays the same. Oh, by the way, this is 2a. So this is 2 times minus 8.5 because A is minus 8.5. So that's 17. So now the square root of 846 is approximately 29. So you have minus 25 plus or minus 29 over minus 17. Now, look, we can only have a positive time. Time cannot be negative. So we're going to choose, the only way we're going to get a positive answer is if we make this minus 29. So we get minus 25 minus 29 gives us minus 54 over minus 17. That gives us plus 3.18 seconds. So that's when the ball lands. That's when the ball lands. Now the next part of the question is, when does the ball reach its maximum height? What is the maximum height? So the time will be the axis, the value for the axis of symmetry, and the h value will give us the height. So the first thing we do for part C, when does the ball reach the maximum height? We use minus b over 2a, and that's minus 25 over 2 times minus 8.5, so 1.47 seconds. And then we put that value into this equation here for h. We substitute x equals 1.47 into replace with the x, and we get minus 8.5 times 1.47 squared plus 25x, 25 times 1.47 plus 6.5. And this part comes out to be, the first term here comes out, use a calculator, minus 18.4. 25 times 1.47 works out to be 36.8. And this works out to be 6.5. So if we take 36 and 6, or the 36.8 and the 6.5, what do we get there? I think we get around 43.3, and we subtract minus 18.4, we get 24.9. So really this represents the vertex. 1.47 is the x value, and the h is the y value, 24.9. And there I've obtained a graph of this, and this is what the graph looks like. Here is the 6.5. It's not the 0. We haven't shown the x-intercepts, so they are further down here. But this is where the graph, as I mentioned before, 2.9 seconds on the way down, where it reaches the height of 6.5, because this is really h equals 6.5 along this line. There's the vertex, and at 1.47 seconds, it reaches its maximum height right there, and the height is, here it says 24.88, which we can round to 24.9. So this is actually a graph of this equation here. This is the graph of this equation, or a part of the graph of this equation. It's just to show you. Remember what I said, the ball starts at a height of 6.5, then it goes up, reaches a maximum, goes down, and reaches that same height of 6.5 after 2.94 seconds, and then goes down, and the graph doesn't show it, but eventually it hits the earth at 3.18 seconds. So this gives you an idea of two problems and how they apply to quadratic equations.